Mr. Larkin, there are still so many words. Don't worry, I'm about to drop some knowledge on your face. Prepare your face. Okay, so here are some words that people commonly mix up. The difference between solubility, concentration, and rate of solution. Okay, so I'll give you an academic definition, and then I'll give you the definition that goes on the streets. Okay? Yo. So concentration is the ratio of solute to volume in a solution, commonly expressed in molarity, which is moles per liter. Okay? And the definition on the streets would be how much stuff is packed in to a certain space. Alright, it's a ratio though. So it's not actually how much there is, it's in a certain space. It's a ratio. Okay, solubility is how much solute can dissolve, not necessarily how much is. That's what concentration is. Concentration is how much stuff is packed in to a certain space, whereas solubility is how much solute can dissolve for a certain volume. And this is often expressed in molarity or grams per liter or other things like that. Okay, so the streets definition is how much stuff a solution can dissolve, which isn't much different than the academic decision. So I don't know if I helped you there. Sorry. Rate of solution is not how much, it's how fast the solute dissolves in the solution. Okay, so how fast. I don't really have a streets definition for that one. I think it's pretty clear. Okay, but let's look at the main differences. Why is this happening? What happened? Fast the solute dissolves in the solution. Okay, now don't go away. Okay, good, it stayed there. Okay, so let's annotate our own notes. So concentration is a ratio of solute to volume. Solubility is how much solute can dissolve, right? How much is able to dissolve, and rate of solution is how fast the solute dissolves. So let's look at a graph to see some differences, okay? So ignore this stuff, but math is useful, okay? So this is the dissolution rate of I don't know what that is. Don't worry about it. But this is rate of solution. So percent dissolved versus time. So let's look at two times. Let's look at 10 minutes and let's look at 20 minutes. Okay, and this is after an hour. Okay, so lines. So after an hour, it gets up to 90% dissolved. Let's say this is its solubility, right? That's how much can dissolve. Okay, so at 10 or 20 minutes, is it at its solubility? No. It can still dissolve more. So its solubility is up here. Okay, but its concentration is the black line. Okay, so at 10 minutes, 60%, it has that concentration. And then at 20 minutes, it has, 75 or something, it has that concentration. The rate of solution is how fast it's happening. So in the first 10 minutes, it goes from 0 to 60. All right, so that's 60% for every 10 minutes. That's on average 6% per minute. So that's pretty quick. For the second 10 minutes, it goes from 60 to 75. So that's 15% for every 10 minutes, which is 1.5% per minute. So it's not dissolving as fast. Now, over the course of the 20 minutes, has the solubility changed? No. It still is only able to dissolve, 90%, and then it stops. It just kind of plateaus there, stops going up. Okay, but for the first 10 minutes, it's dissolving fast, right? A lot of it's dissolving. And then for the next 10 minutes, it's dissolving much slower, and it continues to slow down. The rate of solution goes down as it continues to dissolve. The concentration goes up as time goes on. So the concentration is always going up until it kind of flatlines. The solubility is just always what it is, because the temperature is not changing or anything like that. And the rate of solution is actually decreasing because it's taking longer and longer to dissolve. So I hope that helped you. If not, office hours are Tuesday, Wednesday, or whenever I told you that I would meet with you. Bye-bye.